Last one in this section is going to be more with the calculator. So now we're going to look at finding an angle using the calculator. We're going to do this with an application and with just more of a generic problem. So first one, application. Okay, so a ramp 20 feet in length rises to a loading platform 3.75 feet off the ground. What is the angle of elevation of the ramp? Good question. First thing, draw a picture, right? That's what we always do with a word problem. Well, not always first, but, you know, one of the first things we should do. So, we're going to draw a picture. It's going to be a right triangle. The picture is not to scale. Caution. So, I'm going to call this my angle theta. I know that's a right angle. I know that this is 20 feet. And that's 3.75 feet. And up here, this is the loading platform. So, things are being loaded. There's probably people up here, like, hauling boxes and moving them around and stuff. So anyway, well, what is the angle of elevation of the ramp? That's this angle theta. Let's back up a second also. Angle of elevation. That is always the angle where you have a horizontal and then you are looking up. The angle of depression, which we're not talking about in this problem, but just so you know, that would always be when you have a horizontal and you are looking down. So this would be an angle of depression. This is an angle of elevation. Anyway, back to the problem, right? Okay, so if I have this picture, pause the video. I want you to write a trig function that would utilize theta, 3.75, and 20. Pause the video, do that. Okay, so maybe my directions weren't great, but I meant write a trig equation, sorry. Or write an equation using a trig function. Anyway, so my equation is going to be sine of theta equals 3.75 over 20 because sine of an angle equals the opposite over the hypotenuse. Good. Now, how do I find theta, though? Because that's what the problem actually wants me to do. This is where I'm going to have to use the inverse trig function. Inverse is not the same as reciprocal. We talked about that earlier in the year. So if I look at my calculator, see above the sine button, there's a little sign to the -1. That is the inverse sign. So what this is going to tell me then is theta equals the sine inverse of 3.75 over 20. Now we will formally introduce or define these inverse functions later on in this unit, but for now we can still use them to help us find angles or answer to problems with angles. So now we're going to go to our calculator. This is going to be very important to know what mode we're in. So I look at my mode, I click mode, and I'm currently in radians. We're going to switch to degrees, and I'll explain that in a second. So I'm going to switch to degrees, so now my answer will be in degrees instead of radians. So we're going to type in sine inverse of 3.75 divided by 20. Hit enter. And I get 10.807 degrees. So I know that theta is 10.807 degrees. Okay, now why did I use degrees and not radians? Well, this is an example where degrees make more sense in this case. As far as if I tell you that something is approximately a 10-degree angle, hopefully you have a pretty good number sense of how big that is, or how small that is in this case. Whereas if we were in radians, so let's look, if I just change that back, and then I do that, and then I do the same entry, and then I hit enter, I see that it's 0.188 or 0.189 radians. Well, you probably don't have as good of number sense about radians yet to know approximately how big or small 0.189 radians is. So a lot of times with application problems, degrees are going to be preferred. Now, sometimes it'll specify. If it specifies, follow the directions. Moving on. Alright, so that was an application problem. What if there is just kind of a generic problem? So we did problems like this before, but we used the unit circle. Examples, I might have said cosine of theta is 1/2. Find values of theta between 0 and 360 and 0 and 2 pi. And you looked on your unit circle, you saw pi thirds and 5 pi thirds, or 60 degrees and 300 degrees. And then you got your answers. But here, we can't do that because 0.4512 is not on the unit circle, and negative 1.5 is not on the unit circle. What do we do? Well, here I have to use a little bit of my knowledge and the calculator. So the first thing I'm going to do is I'm going to rewrite this, and I know that theta equals cosine inverse of 0.4512. Let's type that into the calculator and see what happens. For this, it doesn't matter if we're in radians or degrees because we want our answers in both. So I'm going to do cosine of 0.4512. As I'm doing this, emphasize again, reciprocal and inverse are not the same thing. Okay, so I get 1.103. So theta equals 1.103. That is in radians. I know that because, whoops, I quit. My mode is in radians right now. Let's change that to degrees. And that's approximately 63.179 degrees. Okay, now here's the problem though. The calculator gave me one answer in radians and one answer in degrees. These are the same angle though. It's just different units, but same location, right? But I know from my vast knowledge and understanding of my unit circle that there should be an angle in the first quadrant and there should be an angle in the fourth quadrant where cosine equals 0.4512. Think about the example that I erased right here, convenient, right? Where I said cosine of theta equals 1/2, and I said that would be a pi thirds and 5 pi thirds, right? Okay, so how do I find that other angle? Well, I need to think of a relationship between these. Well, here is where I can use the fact that cosine is an even function. And if it's an even function, that means that if this is some theta, this would be negative theta, because the cosine of theta is the same or equal to the cosine of negative theta. So if theta are these two values, then other theta values could be negative 1.103 and negative 63.179 degrees. That's good, right? Except, notice that we want our answers between 0 and 360 and 0 and 2 pi. Now what do we do? Uh-oh, wait. We know about coterminal angles. So I just need to find a coterminal angle of this and a coterminal angle of this. So to find my answers then, I can add 2 pi to this, and I get theta equals 5.180 and theta equals 296.821. And again, what I'm doing is plus 2 pi plus 360. And then that gives me here. What did I put up there? Here. What did I put up there? Okay, so that's how we can find all of our angles. So our answers, I've got a lot going on here. I know, you're like, what is going on? Those are our answers. 2 in radians, 2 in degrees. Good. Okay, I want you to do the next one on your own. Pause the video, unpause when you think you got your answers. Alright, so this one was a little bit more work. First thing, I did tangent inverse of negative 1.5. My calculator was in degrees, so I did the degrees first. I got negative 56.310 degrees. That's a problem though. That's not, whoops, that's not between 0 and 360 or 0 and 2 pi. I'm in degrees, so I care about this one right now. So what can I do? Well, where is negative 56.310 degrees? It is a negative angle in the fourth quadrant, so I found its coterminal angle by adding 360, and that gives me 303.690 degrees. I do the same thing with the radians. If I type this into my calculator, but I'm in radians, I'm going to get a negative angle. I add 2 pi, and I get 5.300. Now, I know that I need another answer, but remember my calculator only gave me one of them, or one location. Well, where's the other location? Well, if tangent is negative, tangent of an angle is a negative value, then in my coordinate plane, it's going to be, or from a circle on my coordinate plane, it's going to be in the second and the fourth quadrant, because that's where the x and y values have opposite signs. So I need to find a location in the second quadrant. Well, what do I know about these two locations? Well, look at this black angle here and this little black angle here. Those are vertical angles. Remember vertical angles from geometry? What do we know about vertical angles? We know vertical angles are congruent. So if this has a measure of, I know it's a negative angle technically, but still the value of it is 56.31 degrees. The negative just gives it direction. That means this angle right here also has to be 56.310 degrees, so I can find this red angle by doing 180 minus that. That's how I get 123.69 degrees. And then I do the same thing in radians. I do pi minus, but in radians, pi minus, and then I get 2.159 radians. Alright, so we use the inverse function on the calculator to find an angle. Be aware of what the angle should be that you were looking for. Similar to that last example, like we got a negative answer. Well, that's not right, but we can still use that answer. It's not that the calculator is doing something wrong. We just have to do a little bit more work.